Hey everyone, welcome to PHYSILOOM. In this video, we are going to explore some numerical problems on electrostatic energy and conductors and electric dipole. And questions we are going to do in this lecture are taken from previous year question papers of IIT JAM and which is explained in the simplest and most logical way, just like you had wanted before your exams. If you are preparing for IIT JAM, JEST, CSIR NET, GATE, or just love physics, you are at the right place. So let's get started. So you can see first question is um, there are three charges. Those are placed on vertices of a equilateral triangle. Okay, and we have to calculate its electrostatic energy. So let's say this is Q1, this is Q2, and Q3. So we know electrostatic energy is given by Q into potential. So we have to assemble these three charges on the vertices of this triangle. So for assembling first Q1 charge at this place, there is no potential present. There is no potential present for Q1. So for W1 for placing Q1. So Q1 and V is 0 because already there is no potential. So W1 will be 0. And for placing charge Q, W2. Now we have taken this charge from infinity at this vertex of the triangle. Because there is Q1 already charge here, and due to this charge the potential is there. Okay, that is Q2 and V1, potential due to charge Q1. Okay, so that will be Q2 potential. Potential due to Q1 is given written like 1 upon 4 pi epsilon naught Q1 over L. L is the length. L is the length of this equilateral triangle. Okay, because all Q are same. Q1 equal Q2 equal Q3, all are same magnitude and positive charges. So this will be given by 1 over 4 pi epsilon naught Q square over L. And W3 will face potential due to Q1 and Q2, both of the charges. Okay, so Q3 and potential due to Q1 is 1 upon 4 pi epsilon naught Q1 over L. It is L distance apart from Q1 plus 1 over 4 pi epsilon naught Q over L. This is Q2. Okay, this is again L distance apart from Q2, and all charges are, we know, all are equal. So 1 over 4 pi epsilon naught, this is Q square over L. Q3 and Q1 will become Q square, and Q3 Q2 also become Q square over L. That is 2 Q square over 4 pi epsilon naught L. Okay, so total electrostatic energy is given by total work done. W is W1 plus W2 plus W3. Okay, so electrostatic energy is given by W1 is 0 plus Q square over 4 pi epsilon naught L plus 2 Q square over 4 pi epsilon naught L. This will become 3 Q square over 4 pi epsilon naught L. So this is the total electrostatic energy. Okay, for this, for assembling these three charges on vertices of a equilateral triangle of length L. Okay, so C is correct option. Okay, so let's move to the next question. And here electrostatic potential is given at any point. So electrostatic potential is given 2x plus 4y. Okay, and what is asked? Electrostatic energy is asked. So electrostatic energy is given by Q into V. Okay, but here this formula is used when magnitude, okay, function of this potential is not given, it is calculated. Like we have to calculate electric potential. In that case, we will use this formula. Else we have another formula for electrostatic potential energy, which is given by 1 by 2 epsilon naught mod E square. Okay, so directly, because potential is given as a function, and here this formula is not of that form. Okay, so first what we will do, we will calculate electric field. We will calculate electric field from this potential function. So as we know, E is minus grad V, is given as minus grad V, and that will become 2 I cap, negative sign outside, plus 4 J cap. So this is electric field, and mode of electric field will be given by mode of E is 4 plus under root 4 plus 16, that is given by under root 20. Okay, so electrostatic energy is given by half epsilon naught and root 20 whole square. Okay, so that will become 10 epsilon naught. So 10 epsilon naught is option B is correct. Okay, okay, so let's move to the next question. And in this question, a charge spherical cell of radius, a spherical cell is given, spherical cell radius is 0.01 meter, 0.01 meter, and its potential is given V equal 30 volt. What we have to calculate? Electrostatic energy. So electrostatic energy for a spherical cell is given by Q square over 8 pi epsilon naught R, but R is given and 8 pi epsilon naught is constant, Q square. Q is not given. How we will calculate Q? So but potential is given, so anyhow we have to calculate Q from this potential. So potential for spherical cell is given by 1 over 4 pi epsilon naught Q over R. Okay, so Q from here we can calculate Q equal 4 pi epsilon naught r and v. Put this value of q here. Put this value of q here. W equal 4 pi epsilon naught r v whole square divided by 8 pi epsilon naught r. Okay, so 4 pi epsilon naught will cancel out. Okay, so 4 pi epsilon naught will remain. This will remain as it is, and v square. So this will be 2. Okay, so 1 over 4 pi epsilon naught equal 9 into 10 to the power 9, and 4 pi epsilon naught will become 1 over 9 into 10 to the power 9. Put it here. This is given by radius is 0.01 into 30 into 30 divided by 9 into 10 to the power 9 multiplied by 2. So 3, 3, 10, 10. This 9 will cancel out. Okay, and 2, this 5. So this will 5 into 0. This will sorry, this is not p. So this will 0.01 multiplied by 5 multiplied by 10 into 10 to the power minus 9. Okay, so this will 0.05 into 10 to the power minus 8, and this will become 5 into 10 to the power minus 10 joule. Okay, W will be this. So B is correct option. B is correct option. Okay, so let's move to the next question. Electrostatic energy in units of 1 over 4 pi epsilon naught. Uniformly charged spherical cell and charge is 5 coulomb. Okay, so from the previous question we have written formula for electrostatic energy for spherical cell. Q square over 8 pi epsilon naught r. So we need not to put the value of 1 over 4 pi epsilon naught, because we have to tell the electrostatic energy in this in 1 over 4 pi epsilon naught units. Okay, so that will be q square over 2r. If we skip 1 over 4 pi epsilon naught, q is given 5 coulomb, so 5 into 5 over 2 into radius is 4 meter given, radius is 4, so this will be 5 into 25 divided by 8, so this will be 3.12 and 5. Okay, 3.125 will be the answer. Okay, very easy question. Okay, so let's move to the next question. Out of the following statement, choose the correct option about a perfect conductor. Okay, so first option is conductor has an equipotential surface. Yes, all conductors have. If the conductor is perfect conductor, so it should have equipotential surface. This is property of conductors. So this is true. Net charge, if any, resides only on the surface of conductor. So this is also true. Okay, any shape conductor, if it is having any charge, so that charge will be distributed to its outer surface. It will not go inside. That's why you are safe in car in rainy season. So this charge will be on the outer surface, will not be inner body. This is also property of conductor. So B is also correct. Electric field cannot exist inside. Okay, so because Q can't be inside the, okay, Q cannot exist inside the conductor body. All the charge, if there is any charge, that will be on the outer surface only. Okay, so any charge will not exist in the body. So if there is not any charge, so electric field also not be there. Okay, electric field cannot exist inside a conductor because there is no charge. Q is 0 inside. So that's why electric field is also not be there. Okay, so this is also correct. Just outside the conductor, electric field is always perpendicular to its surface. Yes. So electric field will be perpendicular to the surface. Like if we draw electric field here, so it will be perpendicular. If electric field here, it will be perpendicular to the surface. So electric field will be always perpendicular to the surface. This is also true. Okay, let's move to the next question. So a arbitrary shaped conductor enclosed a charge q. There is a charge q and the shape of conductor is any arbitrary shape surrounded by a conducting hollow sphere. Okay, and 4 regions are given: 1 2 3 4, 1 2 3 4. These 4 regions are given, and we have to tell which of the following statement is correct. Okay, let's first read first statement. Electric field lines in region 2, electric field lines here, are not affected by the position of charge q. This is false because electric field due to this charge, because this charge is not symmetrically distributed. This charge is not symmetrically distributed. Okay, this charge create electric field, those are not uniform. Okay, because this is not symmetrically distributed over a symmetric surface. This is it is distributed on an arbitrary shaped conductor. So electric field lines will be non-uniform. Okay, so electric field will be non-uniform, and because electric field lines are non-uniform, so it will affect position. Okay, B is surface charge density. Surface charge density on inner wall of hollow sphere is uniform. Okay, so it is talking about what will be the surface charge density here in the inner cavity. It will be uniform or non-uniform, because I have just told you this distribution of charge is not symmetrical. So electric field lines due to this will be non-uniform. And because in the inner layer, the charge is produced due to this electric field. Okay, so induction of charge will mirror this electric field. Okay, because this is not uniform, so charge will also be not uniform, because the high intensity electric field cause induction of more charge, and low intensity electric field cause less charge induction. So somewhere it will be high, somewhere it will be low. So this charge distribution is not uniform. Okay, so this inner charge density on inner wall hollow sphere is uniform, so this is incorrect. This is also incorrect. Let's option C, the surface charge density on an outer surface of a sphere is always uniform irrespective. Yes. Okay, so outer surface charge density, that will be plus, will be uniform because the property of conductor. Okay, so if there is any charge inside a conductor, it doesn't matter where it is. Okay, and where and how it is distributed, it doesn't matter. Okay, so this only depends on how much charge is enclosed, and that charge produces electric flux, and due to that a positive charge will be uniformly distributed over the surface. Okay, so for outer surface, net charge inside, that will only be the factor. So C is correct option. D, electric field in region 2 has a radial symmetry. Radial symmetry will not be there because electric field is non-uniform. Electric field is non-uniform. Okay, due to non-symmetric distribution of charge. Distribution of charge. Okay, so C is correct option. Let's move to next question. Okay, so in this question, two electric dipoles P1 P2 are placed at position, one is at origin and another at x-axis. So let's make this diagram first. So a dipole is here, use another pen. A dipole is here and another dipole is here at 1 0 0. Okay, this is Z, Y, X. Okay, without changing the orientation of dipole P2, this dipole is moved sorry, this is x-axis. Sorry for my mistake. X-axis and y-axis. So this dipole is taken from here to here. This is 1 0 0 0 to 0. Okay, so we have to calculate ratio of electrostatic potential energy. So potential energy, electrostatic energy between two dipoles is given by U equal 1 over 4 pi epsilon naught r cube P1 dot P2 minus 3 P1 dot R1 P2, this is R cap, P2 dot R cap. This is the interaction energy or the electrostatic energy. So as we can see, U is proportional to R cube So in first case r is equal to 1, r is equal to 1, so u will be k over r cube, this will be k, and u1. And in second case it r is equal to 2, second case r is equal to 2, so that will be k over 8. Okay, and what is asked? Ratio is asked. As you can, ratio of electrostatic potential energy of dipoles after moving and before. So ratio is asked. u2 over u1, it is k over 8 divided by k. K will cancel out, that will be 1 divided by 8, 1 ratio 8, 1 ratio 8 will be the answer. Let's check. Yeah, 1 by 8. D is correct option. Go to the next question. Here a electric dipole is given. Okay, and it is asking about, we have to tell which one is correct. So potential falls as 1 over r square, where r is the distance from origin. So let's check. Potential due to a dipole is given by 1 over 4 pi epsilon naught p cos theta over r square. So as you can see, v is directly proportional to r square, so A is correct. Let's check for B. A spherical surface concerned at origin is an equipotential surface. So okay, this electric dipole is placed at origin. So this electric dipole is placed here, and a spherical surface centered at origin. There is a spherical surface centered at origin, and it is asked that it will be equipotential or not. Okay, so we have formula for electric field due to a dipole is given by P over 4 pi epsilon naught r cube 2 cos theta r cap plus sin theta theta cap. So electric field at every point, because it depends on angle theta and radial component. For this spherical surface, r is constant, but theta is not constant, and due to theta, electric field will vary at every point on this sphere. And because electric field is varying, it is decreasing sometime, it is increasing sometime, so potential will also not be constant, because potential is due to the electric field, and if electric field is varying at every point of on this sphere, so potential will also be not equipotent. Okay, so B is correct, not correct. B is not correct. C, electric flux through the spherical surface enclosing the origin is 0, because dipole net charge on dipole is 0, and if there is net charge 0 inside any surface, conducting surface, so there will be no flux. Okay, because negative charge producing flux, negative charged flux, and due to positive charge the flux have both equal and opposite electric field lines. Okay, so that will cancel out the effect of each other. So net flux through any surface will be zero. Yeah, this is correct option. Radial component of E is zero on xy plane. So on xy plane, let's say this, on xy plane, this plane it is talking about, this plane. So on this plane theta will not change, theta will not change, and for any sphere body r is fixed. Okay, this theta is changed, so everything is constant. So electric field radial is P over 4 pi epsilon naught r cube multiplied by 2, because theta is 90 degree, theta is 90 degree in xy plane. So radial component of electric field is zero on xy plane, and theta cos 90 is, put this value here, cos 90 is 0, so radial component will be, ER will become 0. Let's move to next question. So here a dipole of dipole moment PZ located at origin. Which of following is or are correct? This is multiple select question. Okay. So electric field at 0 B0 is 0. Let's check. So first let the potential due to electric dipole is given by, this is theta or theta dependent, and given by P cos theta and 4 pi epsilon naught r square, and electric field that is also r theta dependent is given by P over 4 pi epsilon naught r square. Okay. Sorry, this is r cube, and 2 cos theta r cap plus sin theta theta cap. So electric field at 0 B0. So a dipole is given, this is z direction, this is x direction, y direction. So this is placed here. So at 0 B0, so this will be something here, 0 B0. So it is making an angle of 90 degree. Here theta, angle between this axis and this axis is 90, theta is 90 degree. Okay, so at theta equal 90 degree, sin theta will be 1 and cos theta will be 0. So again ER P over 4 pi epsilon naught r cube multiplied by 1. This is not equal to 0. Okay, so this is incorrect. Option A is incorrect. Option B, work done in moving a charge from Q. Okay, so work done is given by Q and change in potential. So V at 0 B0, 0 0 B, final potential minus initial potential, 0 B0. Okay, and this will be Q using this formula. So at 0 0 B, 0 0 will lie on the z direction, and dipole moment is also in z direction. So theta is 0 0 degree, cos 0 is 1. So this will be P over 4 pi epsilon naught r square. Okay, minus for 0 B 0 0 B 0 B 0 is here. Dipole is in z direction, and this r vector is in y direction. So theta is 90 degree. So cos 90, if we put here 90 degree, so it will become 0. This will be 0. That will be QP over 4 pi epsilon naught and r square. This will be the answer. And here r is B, so we can put B here. So this is correct. Electrostatic potential at B 0 0 is 0. Here electric potential, again theta is 90 degree, again theta is 90 degree. So if we put 90 again, so we will get 0. Okay, so potential is 0. Potential is 0. This is also correct. Electrostatic potential at, and if Q is kept at 0 0 B, it will exert a force of magnitude. It will exert a force of magnitude QP over 4 pi epsilon naught BQ. So let's calculate. So at 0 0 B, so theta is 0 0 0 B, because it is in z direction and dipole also in z direction, so theta will be 0. Okay, and electric field will be, theta is 0, so this component will become 0. So electric field will be 2p over 4 pi epsilon naught r cube from here, and force is given by Q into E, so that will be 2 QP over 4 pi epsilon naught BQ. Okay, so this is not the force, this is not the force, so B is incorrect. Go to next question. Here, charge Q is uniformly distributed over the volume of dielectric sphere. Okay, dielectric sphere. Radius is A, and dielectric constant epsilon r is 2. Ratio of electrostatic energy stored inside the sphere to that stored outside. So we have to tell the ratio of electrostatic energy. So first of all, let us write electric field. This inside electric field is E1, outside electric field is E2. So E1 is given by 1 over 4 pi epsilon naught, that will be QR over A cube r cap, and E2 is given by 1 over 4 pi epsilon naught Q over r square and r cap. Okay, so let us first calculate electrostatic energy inside. So W1 epsilon naught epsilon r divided by 2, and mod E1 square, and this will be from 0 to A. So epsilon naught epsilon r over 2 0 to a 1 over 4 pi epsilon naught and epsilon r. Okay, because it is in inside the dielectric medium, so that's why we are taking another dielectric constant epsilon r here, and q r over a cube and whole square. Okay, and here it will dA. So this will be 4 pi r square and dr. So we can next epsilon naught epsilon r divided by 2 and 1 over 4 pi epsilon naught epsilon r, this whole square, q square over a to the power 6 will come outside 0 to a r square into r square and dr. So epsilon naught and also 4 pi and 4 pi, this will cancel out 1 over 4 pi epsilon naught, so that will be epsilon r divided by 2 1 over 4 pi epsilon naught and epsilon r whole square, q square over a to the power 6, and solving this integral it will give us a to the power 5 over 5. This will cancel out. This will be epsilon r one epsilon r will cancel out, so this will be 1 over 4 pi epsilon naught epsilon r q square over a. Okay, and if I put epsilon r value here, and it will become 1 over 80 q square over pi epsilon naught a. So this is 1. This equation is 1. Let's calculate W2, electrostatic potential outside. So W2 is given by epsilon naught by 2 mod e square and 4 pi r square and dr, and this is from a to infinity, given by epsilon naught by 2 and putting the value a to infinity 1 over 4 pi epsilon naught whole square q square over r square r to the power 4 pi r square and dr. Okay, so next epsilon naught by 2 a to infinity, let's take constant outside first. So this will be 1 over 4 pi epsilon naught whole square q square into 4 pi, and this r square will cancel out 2 times, with a to infinity 1 over r square dr. So this 4 pi epsilon naught will cancel out this square, and this will become 2 square over 2 into 4 pi epsilon naught. This integral will give us 1 by a. Okay, so this will become q square over 8 pi epsilon naught a. Now take ratio of W1 divided by W2. So 1 over 80 q square pi epsilon naught a divided by q square over 8 pi epsilon naught a. This pi epsilon naught a, q square. So and this 8 is 10 times, so this will 1 upon 10. Okay, so this will be 0.1. Okay, so ratio is 0.1. 0.1 is answer. So thank you, and if you like this video, please subscribe and like the video also. Thank you. See you in the next video.